Okay, this is 1.6 part 1. Um, and if you solve this, you're going to subtract 4 on both sides and go x squared equals negative 4. But then you're stuck, right? Because there is no, if you square root it on both sides to get rid of the squared, x equals negative, or square root of negative 4. That's no solution for you guys. But remember back in integrated 3, we learned about this imaginary number concept, that I equals square root of negative 1. Yeah, so if I equals square root of negative 1, then x here can equal negative, or no, not negative, I square root of 4. Square root of 4 is 2, so it's 2I. And please do not forget the plus or minus. Whenever we square root in an equation, we need the plus or minus. Okay, so it's plus or minus 2I. And I, in this case, it has a pattern. I equals square root of negative 1. I squared equals negative 1. I cubed equals negative I. And then I to the 4th equals positive 1. Okay? And I'll show you guys why this is a pattern right now. So you guys can think of I squared as square root of negative 1 squared, right? Well, if you have a square root and a squared, they cancel out, right? So if they cancel out, then that you're just left with negative 1. That's why I squared it equals negative 1. Check. Okay. I cubed. Well, I cubed, we can think about I cubed as I squared. Thank you. Times I. How'd you get it? Oh, sweet. I squared times I. Well, we already established that I squared equals negative 1. So this is negative 1 times I, which equals negative I. Okay, so I cubed equals negative I here. Check. I squared, I to the 4th. We can think of I to the 4th as I squared times I squared, right? Because 2 times 2 plus 2 is 4. So then that's negative 1 times negative 1. What's negative 1 times negative 1? 1. Okay? And check this out. If I to the 5th, I to the 4th is 1, right? I to the 5th, I can rewrite I to the 5th as I to the 4th times I, right? Because 4 plus 1 is 5. So I to the 4th is 1 times I, which is just I. So now I am back to where, let me back this up, to where I started. Okay, let's try I to the 6th. I can guarantee you that it's going to be negative 1. Well, let's see. I to the 6th can be rewritten as I to the 4th times I squared. I to the 4th, because 4 plus 2 is 6, right? Remember, we multiply the powers when we're multiplying like this. I to the 4th is 1 times I squared is negative 1. 1 times negative 1 is negative 1. So we're back to here. So this is just like a cycle that keeps on going and going and going and going. So if I give you I to the 50th, try that. Since this is a recording and not a class, I'm gonna just move on. So 50, you can literally, with I to the 50, go I squared, I to the 3rd, I to the 4th, I to the 5th, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and keep on going until you go 50, right? Or what you can do is go 50, be more efficient, 50 divided by 4, 4 because there are essentially four steps to this, right? So if you do that, I want to do this really quickly. That's 12, 48, and then 2, and then you have a remainder of 2. What this tells me is that the 12 remainder of 2, to get I to the 50, we go through this cycle 12 times, okay? And you have a remainder of 2, so after you go to it 12 times, this will be 47, 48, and then 49, remainder of 2 is 1, 2, right? So remain 49 and then 50. So I to the 50th is negative 1. Okay? All right. And if you guys have any questions on this, please bring it back to the class next time that we do meet. The next concept we have to cover is a complex number. Okay, what a complex number is, it's a number that has a real and imaginary part to it. Okay? So you can think of a complex number as A plus BI, where the A is your real number and BI is your imaginary number. Remember what an imaginary number is? It's a number that has I in it. Okay? 3I, 4I, negative 5I, half an I. Okay? So if I say it's 3 plus 4I is an example of a complex number, that's because the 3 is the real number, and this 4I is your complex number. Or not complex, I'm sorry, imaginary. Okay? And then together, they are a complex number. Okay? So what this first part that we're gonna do is we're gonna add, subtract, and multiply these complex numbers. Okay? So let's first add this guy. Okay? So we have that. And what we're gonna do and how we add it is we're gonna gather the like terms. So we're gonna gather the real parts and we're gonna gather the imaginary parts and just put them together. Okay? It's weird to have a class in here and not be really teaching them. So 3 minus 5, right? I just gathered the 3 and the negative 5. And then plus negative 2i and a minus 4i. Okay, so 3 minus 5 is negative 2 plus negative 2i minus 4i, that's negative 6i. Okay, so this will just be negative 2 minus 6i. Okay, a complex number is it has a real number and it has an imaginary number, and they're just put together with a plus or a minus, right? Okay? Simple, hopefully. Let's try another one. 4 plus 7i plus 7 minus 5i. Okay, you guys can pause the video at any time and try it yourself. Okay? Otherwise, I'm just going to keep going. So 4 plus 7, because that's the real parts. The imaginary parts, it's 7i minus 5i. So 4 plus 7, that's 11. Plus 7i minus 5i, that's 2i. Bada bing, bada boom, you are done. Okay? Subtraction is similar to multiplication or to addition. Okay, so let's try subtracting 3 minus 2i minus, instead of plus, positive 5 minus 4i. Okay? So there's just one step that we add that we're doing before we collect the like terms, is we're going to distribute out this negative to both the 5 and the negative 4i, okay? Or what we can think about, or what we can do, is we can just switch the signs. Okay, so since this is a minus, I'm going to turn it into a plus. Since this is a plus or a positive, I'm going to turn it into a negative. Since this is a negative 4i, I'm going to turn it into a positive 4i. If I do that, I'm literally distributing out the negative. Okay, so that's the same thing. If you just change up the signs, then you should be good. So this is 3 minus 5. So 3 minus 5 plus negative 2i and a positive 4i, negative 2i plus 4i. So this would be negative 2 plus 2i. That's your answer. And it's always going to be real number plus or minus the imaginary number. Okay? That's always going to be the form. All right. Okay. Lastly, what we're going to do is we are going to multiply. Okay? We multiply 4 minus 2i times 3 plus I. Okay? All we do here, class, is we are going to FOIL. Okay, I'm going to try and color coordinate this really nice so that you guys can understand. The F in FOIL is first. So 4 times 3, that's 12. Okay, the first terms, right, of each. Okay? The I, oh, sorry, I don't know how to spell FOIL. The O in FOIL is outside. So the outer terms, right? 4 times I. 4 times I is 4i. The I in FOIL is inside, or the inner terms. So that's the negative 2i times 3, which is negative 6i. And then the L in FOIL is last. So you guys see FOIL. So that's the last terms here and here. Negative 2i times plus I, or times positive I, is negative 2i squared, right? So I see an I squared. Remember, whenever you see an I squared, that's negative 1. So negative 2 times negative 1, or just switch the signs. Okay, just switch the signs. Always. Whenever you see an I squared, cross it off and just switch the signs. If it's a negative, make it a positive. If it's a positive, make it a negative, so on, or yeah. So 12 plus 2, that's 14. 4i minus 6i, that's negative 2i, or minus 2i, and that's your answer. Okay? Cool. All right, and lastly, what I want, or let's do one more example. 3 minus 2i times 4 plus 2i. And then what I want you guys to do is 6 minus 3i times 6 plus 3i. Pause the video and try these two out. Okay. Hopefully you guys did pause it. You guys didn't just fast forward it. So you're just gonna FOIL this out. Foiling this out. Let me actually use the same steps as this, or colors as this. So 3 times 4, that's 12 again. Outside, that's 3 times 2i, that's positive 6i. Inside is negative 2i times 4, that's negative 8i. And then last, negative 2i plus 2, or times 2i is negative 4i squared. So remember, whenever you see an I squared, just cancel it out and just change the sign. That's a plus 4. So 12 plus 4, that is 16. 6i minus 8i, that's minus 2i again. So that's your answer. Okay? Here, we can FOIL. I'm not going to color coordinate it again, but we can FOIL. Okay, so let's try and FOIL. So 6 times 6, that's 36. Outside is 6 times positive 3i, so that's positive 18i. Inside, that's negative 3i times 6, that's negative 18i. And then last is 3i times positive 3i, negative 3i times positive 3i, that's negative 9i squared, right? So whenever I see an I squared, I cancel it out, change the sign. So 36 plus 9, that's 45. Positive 18i and negative 18i, they cancel out. So you're just left with 45. Okay? This is also class special form. So whenever I have the same terms, oops, let me rewrite it here. 6 minus 3i times 6 plus 3i. What I mean by that is I have 6 and 6. I have 3i and 3i, and the only difference is the plus or the minus. That always breaks out to be, or the special form is a plus b times a minus b, right? I kind of switched it up. So a minus b times a plus b, that's always going to equal a squared minus b squared, okay? So 6 squared is 36 minus 3i squared. Well, 3i squared, that's 9i squared, right? Again, I see a I squared, so I cancel that out and make a positive. So 36 plus 9, that's 45. Okay? This here are what we call conjugates. And we're going to use that next time. We're going to use that next time to rationalize my denominator. that is the first part of 1.6 on complex numbers, and I'll see you on the next video.